This is lesson 7.4, in which I will train you to solve rational equations. The learning objectives are to solve rational equations, use rational functions, and solve a rational equation for a specific variable. All right. Well, what is a rational equation? It is an equation that contains one or more rational expressions. Rational expressions are fractions of polynomials. And typically, when we look for a rational expression, we're looking for a variable in the denominator at the bottom of a fraction, okay? Now, when we solve rational equations, we have to always look for extraneous solutions. An extraneous solution to a rational equation is an algebraic solution that would cause any of the expressions in the original equation to be undefined. Undefined means you're dividing by zero. Division by zero is what undefined is. And so we always have to look for extraneous solutions that cause the denominator to equal zero. Okay, here's a how to solve equations with rational expressions step process. So how do you solve equations with rational expressions? Step one, take note of any value of the variable that would cause the denominator to become zero. Step two, find the least common denominator of all denominators in the equation. Step three, clear the fractions by multiplying both sides of the equation by the least common denominator, LCD. Step four, solve the resulting equation. And step five, check. You can check to see if your solutions work in the equation. If any values found in step one are algebraic solutions, discard them. They are extraneous solutions, okay, because they cause the denominator to be zero. But any remaining solutions, go ahead and plug them into the original equation to check to see if you're right. Great. So jumping into our examples, we will have a set of examples in which I will increase the complexity as we go. I'll do the left-hand side. You are always welcome to try the right-hand side as we build our skills. So let's start with step one. Step one, take note of any values of the variable that would cause the denominator to be zero. For example, I'm taking note that this value, if x is turned into zero, well, that would cause this denominator to be zero, right? So x is not allowed to equal zero. If I solve this algebraically and it results in a value of zero, I will say that's an extraneous solution and cross it out. Okay. Next, we're going to take the entire equation at hand and multiply it by the least common denominator. We've talked about how to find least common denominators in the past, so I'm not going to make a big deal out of that in this lesson. I'll do it quickly. So I look at the denominators of x, 3, and 6, and I find out, hey, the LCD is 6x. Why am I multiplying everything by the LCD? Because then I can clear the fractions, and I will not have a fraction in the equation anymore. So my equation's going to be fraction-free, which you guys love. Great. And so multiplying in 6x into each of these fractions, let's find out what we get. Well, if I take 6x and I multiply it by 1 and I divide by x, 6x times 1 is 6x, but then I divide by x, and so my x's cancel, and I have 6. That's all that's left. Okay, so I'm writing the result of multiplying 6x times 1 over x. It's 6. And now I see a plus sign, and so I'm putting that plus sign in my new equation. Next, I'm going to multiply 6x times 1/3. Okay, now I say 6x times 1 is 6x, and then I take that 6x and I divide it by 3, and I get a 2x. Now I have an equal sign, so I write the equal sign in my resulting equation. And lastly, I'm going to take 6x and multiply it by 5/6. And so you could take 6x and multiply by 5 to get 30x, and then 30x divided by 6, well, that just gives you 5x. All right, so I've now multiplied in the LCD into this rational equation, and I got a linear equation out of it. When I cleared the fractions, this results in a linear equation. Why do I say it's linear? Because the highest power of the variable x is 1. Okay, so you have learned strategies for solving linear equations in the recent past. So thinking about this, to solve for x, you would subtract 2x from left to right. And so writing the resulting simplified equation, that would be 6 equals 5x minus 2x, which is 3x. And then we would divide by 3. And so now we have found that x equals 2 is the solution to this equation. Great. So we just solved this rational equation. When we multiplied the LCD, it resulted in a linear equation, and that made it easy to solve. Now, we always want to look back, right? Step 5 said check, and if any values that we found that cause the denominator to equal 0 are a solution, we discard them. Well, the only value that caused the denominator to equal 0 is 0, and we found x equals 2, and so we're safe. There's no extraneous solution. All right, let's proceed forward. So next example. I see 1 minus 5 over y equals negative 6 over y squared. And so first thing to do is take note of any values of the denominator that would cause the variable, the denominator to equal 0. So I look at, this y and this y squared, and I say, well, if y itself was 0, that would cause these denominators to become 0, right? So if I replace y with 0 here, this denominator would become 0. And if I replace y here or with 0, 0 squared is 0, so this denominator would be 0. Okay, and that's the only value that would cause the denominator to be undefined for this fraction. Great. And lastly, this one here, you could take it and divide by 1 to turn it into a fraction. This will help you find the LCD. Now, let's go ahead and take this entire equation and multiply it by the LCD. And the LCD of 1y and y squared is y squared. So I'm multiplying y squared into the first fraction, the second fraction, and the third fraction. And I will write my result. Okay, so my result after doing all of this, well, y squared times 1 is y squared divided by 1 is still y squared. So I get a y squared. Okay, and then take y squared and multiply it by 5. That's 5y squared. Divided by y, well, that's 5y. And there was a minus sign in front of it. Okay, so I have a minus sign, and then y squared times 5 divided by y is 5y. Next, I have an equal sign. Now, take y squared and multiply it by 6, and you get 6y squared. And divided by y squared, well, y squared divided by y squared cancels. And so my result over here is negative 6. Great, I have an equation. And I have no more fractions. That's awesome. And this equation, is it a linear equation like this one was? No, it's not. This is a quadratic equation because the highest power of the variable is 2. And so now I have to get out my skills for solving quadratic equations. And you'll recall that we want to set a quadratic equation equal to 0. So I'm going to add 6 from the right side to the left side. I'm going to add 6. Okay, so explicitly showing you I'm adding 6 from right to left. Great. So I've set this quadratic equal to 0. And the reason why we do that is so we can use the zero product property. And to use the zero product property, we try to factor the trinomial right here. So this trinomial factors to y minus 3 times y minus 2. There you go. And the reason why that's so great that it factors is because it's really easy to find the solutions for y now. The solutions for y, well, this y, 3 minus 3 is 0, so one solution is 3. And 2 minus 2 is 0, so this y's solution is 2. And so I have solved for y. The two solutions are 3 and 2. Now, the only solution that would have been an extraneous solution is a value of 0. And this isn't 0, and this isn't 0, so there were no extraneous solutions in this case. Great. let's move on to the next example. And it looks like this. 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x squared minus 4. Now, if the denominators aren't fully factored, make sure to factor them fully. For example, I see the difference of squares, and so I will factor the difference of squares right here. All right, so x squared minus 4 factors to x plus 2 times x minus 2, which is interesting because I've already got a factor of x plus 2 and another factor of x minus 2 in these denominators. So question comes up, what values of the denominator, right, what values of the variable x cause the denominator to equal 0? And the answer is, if I make this x negative 2 plus 2 would be 0, and that would cause this denominator to be 0. So negative 2 would be an extraneous solution if I got it at the end. And another one is positive 2, because 2 minus 2 equals 0. So positive 2 would cause this denominator to be 0. And then I look at these values in this denominator. Well, negative 2 and positive 2 would cause this denominator to equal 0. So those are repeated again. Great. So I'm going to put a big slash through this equal sign and say x cannot equal negative 2 or positive 2, because that would cause one of these fractions to be undefined. And I'm going to proceed, and I'm going to multiply the entire equation by the least common denominator, LCD. And that is x plus 2 times x minus 2. Right? Those are the only factors we saw in the denominator. We saw x plus 2, x minus 2, x plus 2 again, x minus 2 again. Great, and we are going to multiply these factors of the LCD into all three terms that we have in our equation. Okay, and so now I'm ready to move forward. And when I multiply x plus 2 times x minus 2 into the first fraction, I notice my x plus 2 factor on top cancels the x plus 2 factor on bottom, right? So I'll do that explicitly for you. I'm going to be canceling this with this, you see? And then the 2 of the numerator will get multiplied with the remaining factor of x minus 2. All right. So that's why I'm writing 2 times x minus 2 down here. Okay, now I have the plus sign of the equation, so I'm going to write that plus sign. Next, I'm going to multiply these factors into the second fraction, 4 over x minus 2. And notice with me that the x minus 2 of the denominator will cancel that x minus 2 that's being multiplied in. And so I'm going to multiply 4 with x plus 2. Great. Now I have the equal sign. And I have the denominators of x plus 2 and x minus 2. Well, those two factors will cancel the factors that I'm multiplying in. I'll show you. This x plus 2 cancels that x plus 2, and this x minus 2 cancels that x minus 2. Okay? And so the result is just the numerator x minus 1, since everything canceled. Great. So that was me multiplying in these factors into each of these three rational expressions. And I got this. No more fractions. That's why we multiply by the LCD, to clear the fractions. And now I'm going to solve the resulting linear equation. Everybody, this is a linear equation that results. I'll show you why. Because when I multiply 2 times x and 2 times negative 2 and 4 times x and 4 times positive 2, okay, and that's equal to x minus 1, this equation, its highest power of the variable x is 1. X to the first, x to the first, x to the first. There's no x squared, so it's not a quadratic equation. This is just a linear equation. And strategies for solving a linear equation that we talked about at the beginning of the semester were just get the variable by itself. And so let's simplify where we can. Let's go ahead and add 2x plus 4x, and that gives us 6x. And then let's take the constants negative 4 plus 8, and that makes positive 4, and that equals x minus 1. And so now I'm going to subtract x from right to left. So all the terms with x go to one side, and I'm going to subtract the constant 4 from left to right, so the constants all go to the same side. And 6x minus 1x is 5x, and negative 1 minus 4 is negative 5, and I'm now going to divide by 5, like this, and I find out that, well, x, it's equal to negative 1. Negative 5 divided by 5 is negative 1. Great. And so now let's look back at extraneous solutions. The extraneous solutions would have been negative 2 or positive 2. And this solution is negative 1, which is not either of those, and so there are no extraneous solutions. We're safe. Okay, so there's my final solution for that example. And we are now going to proceed into a new example right here. Okay. So here's the example. And we look at the denominators first. And we say, well, what are the values of m that would cause the denominators to be 0? And first, we need to factor this trinomial to see it clearly. So that's what I'm going to do. I'm going to factor m squared minus 5m plus 4 into m minus 4 times m minus 1. And that's interesting because this factors to these, m minus 4 times m minus 1, but m minus 4 and m minus 1 are the other denominators in this equation. And so what values of m would cause the denominator to equal 0? You would say, well, 4, because 4 minus 4 equals 0, right? So if m is 4, that would cause this denominator to equal 0. And 1. 1 minus 1 is 0. So m is not allowed to equal 4 or 1, right? Let's go through all the factors of the denominator. 4 minus 4 is 0, 1 minus 1 is 0, 4 minus 4 is 0, 1 minus 1 is 0. That's why I'm answering m cannot equal 4 or 1. These would be extraneous solutions if those are the solutions that I find. Now, proceeding forward, now that I have found the possible extraneous solutions, I now multiply the entire equation by the LCD. The least common denominator is m minus 4 times m minus 1. These were all the factors in the denominators. And I'm going to multiply it to all of the rational expressions in the equation. You see? All the terms in the equation. Now, proceeding forward, I'm going to write the result of this. And what I notice as I multiply m minus 4 times m minus 1 into the first fraction is the denominator has m minus 4 and m minus 1 in it. And so this m minus 4 and that m minus 4 cancel, and this m minus 1 and this m minus 1 cancel. And the result is just m plus 11. And so I'll write that down below. I have m plus 11 to start off my resulting equation. And that equals, right? I see the equal sign right here, so I write it. Now, moving on to this expression, multiplying in the LCD, m minus 4 cancels m minus 4. This m minus 4 and this m minus 4 fight and die. And 5 is multiplied with m minus 1. That's why I'm writing 5 times m minus 1 right here. And now I see the minus sign, so I write the minus sign. And now I'm multiplying m minus 4 times m minus 1 by the last fraction. And I notice the factors that cancel on top and bottom are, well, this m minus 1 cancels this m minus 1. And so 3 is going to be multiplied with m minus 4. Let's go ahead and do that. m 3 is multiplied with m minus 4. There we go. Great. And so now that I multiplied this rational equation by the LCD, I now have this resulting equation. And I'm going to solve it for the variable m. And, you know, as I start to distribute stuff, I notice this is a linear equation. So I'll write out the linear equation. M plus 11 equals 5m minus 5 minus 3m plus 12. And by the way, remember this negative sign distributes in here with this 3. So this is negative 3 times m and negative 3 times negative 4. So don't mess up your signs. Great. So we're to this point, and we have a linear equation. So let's simplify it. Let's make it look easier. M plus 11 equals, well, 5m minus 3m. I'm combining like terms, and I get 2m. And negative 5 plus 12, which gives me a positive 7. Okay. And now what I'm going to do is I'm going to, move some terms around because I want to get the variable terms by themselves on one side of the equal sign. So it would make sense why I might subtract m from left to right and subtract 7 from right to left. Great. And what do I get as a result? Well, 2m minus 1m is just m, 1m. And, well, 11 minus 7, that's 4. So I have now solved this linear equation, and I found out that m equals 4. And at this point, I need to go back to check what would have caused me to have extraneous solutions. Well, I said at the beginning, m is not allowed to equal 4 or 1. I took notes on that, right? And so now I go down and I say, well, I just solved this equation with algebra, and it says m equals 4. But that's one of the values that it's not allowed to be. And so I go and I cross out that solution. I found an imposter. I found an extraneous solution. Okay? Great. And so the real answer to this equation solution is that there's no solution. The only solution that I found was an extraneous solution, and so there is no real solution to this equation. Great, so that was our first extraneous solution that we have found so far in this lesson. Let's try a couple examples and see if there are extraneous solutions that appear in some of these other ones. Great, so I have 2 more examples for you before we move on to a next objective. We're just building your skills with solving rational equations. And so here is our next equation. And let's go ahead and analyze the denominators of these rational expressions. So the first denominator is y plus 6. This next denominator is y squared minus 36, which you'll immediately recognize as the difference of squares. And so you'll factor the difference of squares into y plus 6 times y minus 6, right? Great. So always look for factors, things that you could factor further. And then it might be nice to turn this 4 into 4 divided by 1. So you see, the denominator of this fraction is 1. Great. So now let's take note of what the value y cannot be. Y cannot be, well, negative 6, right? Because negative 6 plus 6 would be 0. This denominator would become 0. Can't be negative 6. And it can't be positive 6 because positive 6 minus 6 is 0. And so that would cause this thing to be 0, and 0 times this is just 0. Okay, so these are the values that y cannot be. So I put a slash through the equal sign. Y cannot equal negative 6 or positive 6. Great, now that I took note of the possible extraneous solutions, I'm going to move forward and multiply the entire equation by the LCD. And the least common denominator of this denominator, and this denominator is y plus 6 times y minus 6. And I'm going to multiply these factors into all of the terms of the equation, one at a time. And so, when I look at the first expression that I'm multiplying these into, I see a y plus 6 in the denominator. And so this factor right here, y plus 6, will cancel that y plus 6. And y right here will be multiplied with y minus 6. So that's how I'm going to start writing my equation, y times y minus 6. And I'll write it right here, y times y minus 6. Great. Now I have an equal sign. So I write the equal sign of the equation. And now moving forward, I have this 72 divided by y plus 6 times y minus 6 that I'm multiplying this y plus 6 times y minus 6 into. And notice, yeah, y plus 6 cancels y plus 6, and y minus 6 cancels y minus 6. And so all I get is a 72. And I'll write that next, 72. Okay, now I get to the plus sign of the equation, so I'm going to write that plus sign here. And next I'm going to multiply in the LCD into this plus 4 over 1. Now, nothing from the LCD cancels in the denominator here, so I'm going to multiply this 4 by both of these factors. Okay, so I get a 4 times y plus 6 times y minus 6. Like that. Great, so this is the resulting equation. So I can ignore everything that I just worked on and just focus on this resulting equation, trying to solve it for y. And first we would, do distributions. And in this case, we would FOIL, right? So I'll clean it up. I'll show you the process. Y times y is y squared, and then I have a minus 6y, and that equals 72 plus 4 times, well, y times y is y squared, y times negative 6 is negative 6y, 6 times y is positive 6y, and 6 times negative 6 is negative 36, right? And yeah, this outer and inner terms of FOILing will cancel. And what it does is it just gives us back that y squared minus 36 that we had right here, right? Because that was the factored version. Great. And now I'm going to distribute this 4 into that y squared term and that negative 36 term. And let's start to clean it up little by little. So I have a y squared minus 6y equals 72 plus 4y squared, and then minus, well, 120 and 24, 144. Sounds good to me. Great. So I get to this point, and now I notice, well, this is a quadratic equation because the highest power of the variable is 2. And so I'm going to use solution methods to quadratic equations we've learned in the past, and that is to set a quadratic equation always equal to 0 and then try to factor. Let's see if that works out for us. Okay, so to get it done, I'm going to subtract y squared from this side to this side. And then I'm going to add 6y from this side to this side. And then I'm going to combine any like terms as I go, right? Why did I do that? Because all of this will cancel and become 0. So I'm setting this quadratic equal to 0. And I'll write the result over here on the right, just giving myself a little bit of space. 4y squared minus 1y squared is 3y squared. And I have a plus 6y. There were no like terms with the 6y. And then 72 minus 144. 72 minus 144, that gives me, let me do that really fast. I want to make sure I get it right for you guys. Okay, 72 minus 144, that gives me a negative 72. There we go. Great. And I'm setting this equal to 0 because, right, I got this stuff over here. It's now 0. This stuff now equals 0. Great. So there's my quadratic, set equal to 0. I notice there's a GCF immediately, right? 3, 6, and 72, all multiples of 3. So my GCF is 3. I'm going to factor it out. I have a y squared plus 2y minus 24. That equals 0. And now I'm going to try to factor this trinomial, and it works. I can factor it into y plus 6 times y minus 4. That'll work. Great. And so my solutions for y, we're all the way to the end now. My solutions for y are that it can equal negative 6 or positive 4. I'll explain that really fast. This y is negative 6 because negative 6 plus 6 is 0. And this y is positive 4 because 4 minus 4 is 0. And so I have found the solutions. Great. And so the last thing to do is compare the solutions that we found with the possible extraneous solutions. We said at the beginning, the values that cause denominators to be 0 and the expressions to be undefined are negative 6 and positive 6. And here in my solution, I see a negative 6, and so I'm going to cross it out. That's an extraneous solution. But 4 was fine, right? 4 wasn't part of that. And so y equals 4 is the only solution to this rational equation. And let's go ahead and jump into one last example of this objective. Okay, so here I go, and I see the denominators, and I notice I'm going to have to factor. It's time to start factoring. Okay, so I'm just going to look at these denominators. I'm going to factor them first before I do anything else. Great, and for the first one, I think about it, and I get 3x minus 1 times x minus 3. And for the second one, I get a 3x minus 1 times x plus 1. And for the last one, I get an x minus 3 times an x plus 1. Right, so these are your factoring skills coming back out. And we have factored completely. And now I'm going to create a list of the things that x cannot be. Right? So what can't x equal? Well, in this case, it can't equal 1/3, right? Make this opposite divide by this. If you set this equal to 0 and solve it for x, you would add 1 and divide 3. And so it makes sense that x cannot equal 1/3. And now for this one, 3 minus 3, that's what equals 0. So x cannot equal 3 itself. And then for this one, negative 1 plus 1 is 0, right? Negative 1 plus 1 is 0. So x cannot be negative 1. And those same values repeat again. So these are the three things that x is not allowed to be. Okay? So that's just taking note at the beginning of the possible extraneous solutions that I might have. Okay, now that we have found the possible extraneous solutions, we can now multiply the entire equation by the LCD. And the LCD is, the factors of the denominators, like 3x minus 1, right? It's here and here. So I just put 3x minus 1 one time. Okay, so there's the first factor of the denominator. I also see an x minus 3, and I also see an x plus 1. Okay, so these are the three factors that are in the denominator. 3x minus 1, x minus 3, x plus 1. Okay, 3x minus 1, x minus 3, x plus 1 are repeated again. I only have to put them once. And now I'm going to multiply these factors into the first expression and the second expression and, yep, the third expression as well. And so I'm going to write down below the resulting equation. And you'll notice this 3x minus 1 and this 3x minus 1 cancel, and this x minus 3 and this x minus 3 cancel. And so 4 is multiplied with the remaining factor x plus 1. Okay, so that's why I have 4 times x plus 1. Now I have a plus sign. I write the plus sign. Boom. Okay, moving on to the second expression here. This 3x minus 1 cancels that 3x minus 1, and this x plus 1 cancels that x plus 1. So this 3 is multiplied with the only remaining factor of x minus 3. So I have 3 times x minus 3. Great. Now I have an equal sign. I write the equal sign, and I move on, and I notice, well, this x minus 3 and that x minus 3 cancel. This x plus 1 and that x plus 1 cancel. The only remaining factor that I'm multiplying in is 3x minus 1, and I'm multiplying it with 2. So I have a 2 times 3x minus 1. There you go. I hope I've been useful in explaining this process to you. I'm going to move forward with this resulting equation, and I'm going to simplify it all. I'm going to combine like terms. I'm going to try to solve for x. That's my goal. And I get a 4x plus 4. plus a 3x minus 9 equals a 6x minus 2. And I get happy because this is a linear equation instead of a quadratic equation that I have to solve, right? And I combine like terms like 4x plus 3x to get me the 7x. And then I combine like 4 and negative 9 to make negative 5. Okay, and that equals the 6x minus 2 over here. And it might make sense that I would want to subtract 6x from right to left and then add 5 from left to right. Okay, and my result is 7x minus 6x, which is 1x, and that's equal to negative 2 plus 5, which is 3. And so I have solved this equation, right? It's x equals 3. But now that I have solved the equation algebraically, I look back for extraneous solutions. And you'll be interested to see that 3 was one of the possible extraneous solutions. That 3 would cause the denominator to be 0 and the equation would then be undefined. And so I'm going to X out my only solution. My only solution was 3. And so I will now have to say that there is no solution because the only one I found was extraneous. Great. Well, thank you for joining me in that process. We have a couple more objectives before we finish off this lesson, and so I'll move forward. The next is to use rational functions, right? And so a rational function is just a function in which it's equal to a rational expression. A function is set equal to a rational expression. And the first objective says to find the domain of the function. We did that in a previous lesson. And so let me help you remind you how that happens. What we do is we set the denominator equal to 0 and we solve for the variable. Okay. And when I do that, I find out, well, x squared minus 8x plus 15, it factors into x minus 5 times x minus 3. And then I find that the solution to this is x equals 5 and x equals 3, right? This x is 5 because 5 minus 5 is 0. And this x is 3 because 3 minus 3 is 0. These are the solutions. Okay, and those solutions are what cause the denominator to equal 0, right? That's what we said. So our domain is not allowed to include them because they cause the rational expressions to be undefined. And so x is allowed to be all of those numbers, all numbers from negative infinity to infinity, except for the values of 5 and 3, those two values. Now, how do I represent all values from negative infinity to infinity? With a fancy R. Yeah, it's this R with 2 lines, right? And then I trace the rest of the R. This R represents all real numbers in algebra. Okay, so when I see that R, my brain thinks all numbers for x from negative infinity to positive infinity. Well, except x is not allowed to equal 5 or 3. Those are the only two exceptions. And this is the domain of all the x values of this function. Great. So that is how you find the domain of a function. And rational functions, right? They have domain restrictions. They have things that x is not allowed to be because they cause the denominator to equal 0. Moving on, part B says solve f of x equals 1. Well, it was stated that f of x equals this stuff, and it's also stated that f of x equals 1. So f of x equals these two things, which means they equal each other. And so I will create an equation that says 2x minus 6 divided by x squared minus 8x plus 15 equals 1. And this is a rational equation. Okay, so we're going to get out our strategies for how we solve rational equations. And, from the beginning, we would say, okay, well, x is not allowed to equal 5 or 3, right? Because those are the values that we discovered up here cause the denominator to equal 0. Okay, so now that we have found the exceptions to what x is allowed to be, we are now going to multiply this entire equation by the least common denominator, which happens to be x minus 3 times x minus 5. Okay, so x minus 3 times x minus 5. How did I get that? Well, the only denominator in this equation is this trinomial, and it factors to this. We already factored it. Okay, and so x minus 3 times x minus 5, those are the factors that are the LCD. And so now I'm going to distribute those factors into both of these terms here and here. And what's really nice is that this x minus 3 and x minus 5 cancel this trinomial, right? When I multiply them in. Let me explain why. Because this trinomial is literally x minus 3 times x minus 5. It's those factors multiplied together. All right, so my resulting equation is just 2x minus 6. And then I take this x minus 3 times x minus 5 and I multiply it with 1, right? And that's it. That's the result, which I can write as the trinomial x squared minus 8x plus 15. Because if I FOILed x minus 3 times x minus 5, I would get that. Okay, so this is my resulting equation when I multiplied the LCD. Why is this so good? Because I don't have any more fractions. Okay, so no more fractions. We can now proceed to solve this equation. And this equation is a quadratic equation, so I'm going to set it equal to 0. So I subtract 2x from left to right, and I'm also going to subtract 6, or sorry, add 6 from left to right, right? Okay, so that causes these to cancel. And I now have an equation that says x squared minus 10x plus 21 equals 0, right? So x squared, negative 8x minus 2x is negative 10x, 15 plus 6 is 21, and it now all equals 0 because this stuff canceled. And now let's factor that. Is that a trinomial that's factorable? Because then I could use the zero product property to solve for x. And it does factor to x minus 7 times x minus 3. Great. And so the solutions for x are x equals, well, this x equals 7, because 7 minus 7 is 0. Great. And this x is 3, because 3 minus 3 is 0. And I have found my solutions to this equation. And I look back for a second and I say, well, what were the values that caused the expressions to be undefined? Those are 5 and 3. Okay, well, 3 was one of my solutions. So that's extraneous. I'm going to cross it out. But 7 is safe. 7 wasn't one of those options. And so my only solution that I will report is x equals 7. Great. Now, part C, it says find the points on the graph at this function value. And, what's funny is this function was set equal to 1 for the y value when the x value is 7. And so this answer is really quite simple. Connecting these ideas, it would be 7 comma 1. The x value is 7 when the y value, f of x, is y, it's 1. 7 comma 1 is a point on the graph of this function. Cool. Moving forward to the last objective today, solve a rational equation for a specific variable. All right, and so here's a rational equation. It's an equation that has a variable in a denominator of a fraction, so it's a rational equation. But they want me to solve it for y. When they say solve for a variable, they mean get that variable by itself. Currently, this equation is solved for m. M is alone, but we want y to be alone. And so let's get out some strategies to solve for y. Well, first, I would multiply this denominator, x minus 3, from the right-hand side. Just multiply x minus 3 on the left and right of this equation. And that would cause this x minus 3 and this x minus 3 to cancel, right? So we can multiply the factor x minus 3 to both sides of the equation, and I will rewrite it. We now have x minus 3 times m, or we could put the factor m in front. That's always nice to do. M times x minus 3, that's equal to y minus 2. And lastly, we can add 2 from right to left. And now we've gotten y all by itself. So m times x minus 3 plus 2, that's what y equals. That equals y. Okay? So now we have solved this equation for y. We got y by itself by using some algebra skills. Great. And last example today is take this rational equation and solve it for c. Okay? That's our last objective today. Take this rational equation, solve it for c. And so, what I would do is I would multiply the entire equation by the LCD, right? So what is the LCD here? I'll do it in red. Well, the least common denominator is c and m, right? C times m, because those are the denominators in question that we have here. And so I'm going to distribute c times m into all of these pieces, and let's see what the resulting equation is. Well, this c cancels that c, and 1 is multiplied with m. So 1 times m is just m. And then this c times m gets multiplied with this fraction 1 over m. So this m cancels this m, and 1 is multiplied with c. So I get a plus c. And now that equals, well, c times m is multiplied with 1. 1 times c times m. Well, then that's just c times m. Great. And so now we have cleared the fractions by multiplying by the LCD. Now, my goal is to solve for c, okay? And so I'm going to get all my terms with c in them to the same side of the equation. That's why I'm subtracting c. And I get m equals cm minus c. And at this point, man, I'm trying to solve for c, but like c is in both of these terms. And when you have the same value that you're trying to solve for in two terms, you can factor it out of those two terms. And so it would make sense that I have m equals c times m minus 1. When I factor c out of these two terms, then I'm left with m minus 1. And the last thing to do to get c alone, now that I factored it out, is divide the factor m minus 1 from right to left. Okay, great. And so now my result is that c is equal to m divided by m minus 1. And I have solved for the variable c, and we have completed this lesson. 7.4, it was a good one. Thank you very much, and have a wonderful